ground-level tracking shot moving rapidly over the surface of the drying beans. The camera glides inches above the cocoa.
The camera zooms in microscopically to see the tiny grains of sand and dust falling through this second screen. It is a dual.
This shot validates the necessity of the process, showing exactly what would have ended up in the chocolate if this massive machine hadn't intervened.
This shot explains how the machine differentiates not just between beans and dirt, but between good beans and bad beans.
The dust cyclone extraction. We see the air swirling rapidly inside the transparent inspection window of the cyclone.
The beans are floating on a cushion of air, behaving like a fluid flowing downhill. The heavier stones sink.
This is the final density check. The lighting is bright and revealing, ensuring no stone is left to crack a tooth or break a machine later down the line.
The beans enter a stainless steel pressure vessel. The heavy steel door seals shut. High-pressure steam is injected.
The silo storage buffer. The clean beans are not immediately roasted. They go to a buffer silo. This upward momentum physically moves the narrative to the next phase. Heat.
This visualization explains the science. We are roasting the shell to make it brittle, but protecting the delicate nib inside from burning.
The transition to the crusher, or breaker. They hit a pair of hexagonal steel rollers spinning at high velocity. The brittle, roasted shell shatters. This machine uses gravity and aerodynamics to solve the puzzle of separation.
The physics of separation in ultra-slow motion. The camera focuses on a specific interaction point inside the window.
The nib collection stream. The camera returns to the bottom of the winnower. A stream of pure, clean cocoa nibs pours out onto a conveyor.
We see blue flames jetting out with immense pressure. The temperature climbs past 120 degrees Celsius.
Oil bleed. As the temperature hits 140 degrees Celsius, the cell walls of the nibs begin to break down. The hot nibs land on a large, circular, perforated metal tray. Giant rotating arms immediately spread them. A time-lapse shot of the cooling tray. We see the nibs stopping their motion and settling. The roast is locked.
Transition to the next phase. The cooled nibs drop through a trapdoor in the center of the cooling tray belt.
The roasted, cooled nibs are traveling on a high-speed belt. They are dry and brittle. They cascade off the end of the belt into
The emergence of cocoa liquor. This is not alcohol. It is pure liquid cocoa mass.
Roughly 50% fat, 50% solid. This machine has one job: to rip the butter out of the liquor. Compression begins. 1,000 psi, 2,000 psi.
the first weep, the separation.
The pressure hits 5,000 psi. We see the miracle of separation.
The peak pressure, 9,000 psi. The machine reaches maximum compression. The sound is a deafening, strained hum. The heavy cakes are ejected. They fall with a heavy, dull thud onto a conveyor belt below. One cake hits another.
This material will be pulverized into powder later, but for our story, it represents the solid fraction of the bean.
The weighing station shows the separation. The flow meter counts gallons of cocoa butter, and the scale weighs kilograms of cocoa cake.
The extracted butter is slightly cloudy. After passing through the filters, it becomes crystal clear, like on the left, dark, thick cocoa liquor. On the right, clear, golden cocoa butter. This sets the stage.
A second chute opens and a different white substance falls. This is full cream milk powder.
The kneader action. The massive double-armed steel blades begin to rotate. These are not whisks, they are heavy,
The cork force falls into the nibs between two large multiple men. These are the crushers.
is the monster of the factory, the 5-roll refiner.
This is the gatekeeper of smoothness.
The rough flakes from the pre-refiner travel up a conveyor and are dumped into the bottom gap. The paste accumulates here.
The camera visualizes this shear. The faster roller grabs the chocolate from the slower one. This difference in speed literally tears the particles apart.
The chocolate film travels upwards, zigzagging from roller to roller. The gap gets tighter and the speed gets...
A single sugar crystal approaches the gap. It is too big. As it hits the steel wall, it explodes into dust.
The cooling of the hollow rolls. These rollers generate immense heat from friction. If they get too hot, the chocolate will burn.
The refined flake texture. The camera focuses on the material falling from the scraper blade into a collection trough. These are the refined flakes.
The laser diffraction sizer. An automated laser sensor scans the falling curtain of flakes. This is the scientific validation of the mechanical crushing.
The dryness paradox. The camera lingers on a close-up of the moving powder. It looks incredibly dry and thirsty. This sets up the conflict for the next phase. Transition to the conche. The conveyor belt carries the dry powder towards a dark, cavernous opening in the floor, a chute leading to the next level.
The generation of frictional heat. The heat comes from the physics of friction. The steel wall glows orange, and the streak of powders.
The mixture now looks like thick, brown modeling clay or heavy dough. It tears rather than flows.
This is not just steam. It is acetic acid and other harsh, volatile compounds evaporating from the cocoa.
The specific design of the conche throws the chocolate into the air.
The addition of the magic drop, lecithin, a stream of amber, honey-like liquid is injected into the chocolate.
Final cocoa butter adjustment. The recipe calls for a specific mouthfeel. We see a final stream of clear, melted cocoa butter being added to the mix.
This shot emphasizes the element of time. It is not just mixing, it is aging. The patience of the process.
The chocolate pours off the edge. It falls in a continuous, twisting ribbon. It folds over.
The camera dives into the liquid once more. We compare this view to Phase 5. Now, we see perfectly round.
We see the emergence of roast notes and caramel notes swirling within the brown texture.
The filter station. Even after all this, we take no chances. The liquid chocolate passes through a final vibrant sieve.
The chocolate is pumped into gargantuan holding tanks. Inside, a massive propeller keeps the liquid moving slowly.
Transition to the tempering line. The final shot of Phase 6 follows a pipe leaving the storage tank. The pipe is wrapped in insulation.
The first cooling zone. Crystal formation. The temperature drops rapidly to
the reheating zone. The temperature is gently raised to 31.5 degrees Celsius. This is the mellowing phase.
It looks different now how it has a satiny, viscous sheen. It is in temper. It is now...
the mold preheater. Before the chocolate can be poured, the molds must be warm. If they are cold, the chocolate will shock set and turn gray.
Then, the valve rotates. The piston drives forward. The pressure builds. The chocolate is forced out of the nozzle.
The suck back, clean cut. The dosing is finished. The flow must stop instantly to prevent trailing strings of chocolate.
The camera tracks the nozzle moving laterally across the mold as it fills. We see a zigzag pattern of chocolate.
Variety shot, we see a nut spreader. A waterfall of roasted hazelnuts or almonds falls from a hopper. The camera captures the nuts hitting the wet surface of the liquid chocolate.
The leveling effect. The vibration also flattens the chocolate. Initially, the pour was uneven.
Camera captures the blade skimming just a millimeter above the plastic rim. It catches a wave of excess chocolate and pushes it off the side into a remelt channel.
The camera tracks the molds entering the mouth of the cooling tunnel. The environment shifts abruptly from the
physics of contraction. This is the most critical moment in the tunnel. As cocoa butter crystallizes, it shrinks by about 2% in volume.
The mold twist station. The molds pass through a mechanical twisting device. The rails twist slightly in opposite directions. The pneumatic hammers. To ensure every single bar drops, the molds pass under a series of rapid-fire hammers. These are
The metal detector gateway, the first line of defense. The rows of bars pass through a rectangle.
The software analyzes the topography. It looks for surface scratches, fingerprints, or bloom.
The X-ray chamber.
The bars race over a split belt section that acts as a dynamic scale. The belt itself weighs the product while it is moving.
The buffer accumulator. Sometimes the wrapping machine downstream jams. To prevent stopping the oven or depositor,
The high-speed convergence belt.
We see the colorful branding streaming off the roll. The camera zooms in on the registration mark. A laser sensor
Fin seal creation.
Two heated, serrated wheels pinch the bottom edges of the foil together. The heat seal coating activates instantly, melting the seam shut.
The rotary jaw cutter.
Exit cone acceleration. Once cut, the individual bars are released. The exit moves faster than
the check weigher, final pack. The wrap bars race over a sensitive scale. Unlike the earlier check, this one confirms the gross weight, chocolate, and wrapper.